In this video, we'll talk about how you can determine what each piece's degree measure is, whether it's an angle or an arc. We'll also talk about how to name all the different arcs in each of the following pictures. So if we take a look, I'm going to use a lot of different colors. Okay, so got all my colors ready. Probably need about 4 just to be safe. But yeah, let's take a look at the first guy that's already filled in. So notice it's already filled in. It started off by telling us that angle BAE. So again, follow the path. Okay, stay on the lines. Don't stray from the path. We start at B. We go to A. We go to E. It told us this angle right here is 40. Well, because it's at the center, that means the arc is the same. Because remember, central angle equals arc. Okay, so central angle equals arc, which means that I can complete my pizza slice here and give myself some crust. All right, so that means that this arc out here is also 40. So minor arc EB is 40, or minor arc BE is 40, hence why they got the 40. So we confirm that, we check it off. All right, it also told us that minor arc CD is 100. Okay, so we have this minor arc over here. This minor arc over here, which is 100, which means that angle DAC, because I got to complete my pizza slice, we have a central angle, so angle DAC is 100. And if we check and see, do we have a DAC that we need? No, so we're good. Okay, so that's all the information they gave us. Now there's a couple of things that we need to be aware of. Okay, there's a couple of things that we need to be aware of. And the first thing is going to be, when we're doing these kind of problems, we look for 2 things. So look for 2 things. We look for vertical angles at the center, and we look for diameters, because they equal 180. These will be congruent. Okay, so 2 things. Vertical angles at the center, diameters being 180. So if we look at our picture here, notice at the vertical angle here, we don't really have any good vertical angles to help us. So that's not very helpful. Okay, then we move on to diameters. Well, if I look here, EC is a diameter. It even told us EC is a diameter, which means that on both sides of EC, here in green, that means the arc is 180 degrees because it forms a semicircle. Okay, and I'm doing them both in green because they're the same amount. Okay, so I have 2 sides where it's 180. Well, if I cover one side, if I put my pinky finger on the diameter and cover up, see how I have 2 pieces? Doesn't this kind of sound like a part plus part equals whole problem? Where if I'm doing this problem, I have right here, in order to find minor arc BC, I can say that arc EB plus arc BC is equal to 180, which means that now I can say 40 plus x is equal to 180, or x equals 140 by doing some algebra. So now I know that this piece is 140. Well, if I cover it up again, I can now see, all right, once again I have a piece that's 100. Once again I have a part plus part, so I can say arc CD plus arc DE equals 180. And I can do the same math. I can plug stuff in, so I know that CD was 100 plus x is equal to 180. So x is equal to 80. And now I know that this piece is 80, which means that that arc is 80, and that this arc over here is going to be the 140 that we were looking for. Okay? So, and then we can fill in our chart based on stuff. So, like, for example, arc BC, we saw that that was 140. We can check that off. We're good to go there. Angle BAC, which is the same as arc BC, also 140. We're good there. We see that arc DE is 80. We see that angle DAE, which is the same pizza slice as arc DE, so it's also 80. Arc DB, so this big arc has two pieces. That's an 80 and a 40. If we add those up, we get 120. Which means that angle DAB also 120. And then we found our arc DC here, which was 100. That was given to us earlier. Okay? So that is how we do this. Let's do one where it's not filled in. We're going to do this bottom one because it's a little harder. And in class, I do this middle one. So we're going to do this bottom one just to save us some time. Okay? Actually, you know what? We'll do all of them. All right? I'm going to go a little quicker since I did a lot of explanation here and get through this. So here we go. If you want to pause the video at this point and try it on your own and then check, that would be a great opportunity. But here we go. EAF is a big piece right here. It's 110. Okay? I immediately notice that there is a vertical angle here and here. There are vertical angles. So that I can see now that this guy, this piece right here, is also 110, both at the angle and the sector. Okay? It then tells me that BF, so this guy right here, is 60, which tells me that this piece right here, BE, because it's inside my 110 piece, and this is 60, I can do 110 minus 60 and get 50. Like so. Now, I see I have vertical angles. I already took care of one of them. I have another set of vertical angles, but I don't know the piece yet, and I don't have any information to help me. But what I do have is this diameter right here at EC, which I can use by covering up and seeing, okay, I know this has to be 180, so I know this big piece right here has to be 180. I have a 110 already, which means that this guy right here, it's got to be 70, because 180 minus 110 is 70, and because of vertical angles, that means this guy is 70. And so as we see, I did that really, really quick, but by using my highlighters and colors and looking for my two things, I was able to figure out every sector super quick, and now I can fill in my chart. Arc BE was 50 degrees. Arc BC had two pieces, 60 and 70, so it came out as 130 degrees. BAC is the same as arc BC, so 130 degrees. Arc DE was 70 degrees. Angle DAE is the same as the arc, so 70 degrees. Arc DB has a 70 and a 50 piece, or 120 degrees. Angle DAB has the same two pieces, so 120 degrees. And an arc DC, 110 degrees. Okay? Now let's name all the semicircles. So we have 4 potential semicircles. So we could have arc EDC, arc EFC. And again, if you hit multiple letters, like on this arc, notice I could hit B or F on my way to C. Then I could have also arc EBC. It doesn't matter, but you need at least 3 where the 2 of the letters are your end points. Your start and your end. Okay? The other ones would be on this diameter. So I could have arc FBD or arc FEB or arc FCD. Okay? And so that is all of the potential semicircles. Okay, notice I used 3 letters for a semicircle. Okay, last example. So if I have angle EAB equals 45, so EAB, my pizza crust, we have a central angle because it's at the center, is 45, which means the arc is also 45. And then it tells me major arc ECD, so ECD. Notice I didn't go this way. I went on my path to the next letter. So E, C, and D. Okay, which results in it being 280 degrees. Okay, notice I have 3 parts. So I got to go and figure out my various parts. Now, I see here that I don't have any vertical angles, so that does me no good. But I do have a diameter again. So I have a diameter. So I know that this side is 180 and this side is 180. Well, I have an angle here and I have 2 parts in that diameter, so I can cover it. I can do 180 minus 45 and get 135 for this piece. And now that I know that, I can add these two together and subtract from 280 to get this piece. So let's do that. So we have 280 minus 180, which means that this is 100. I could have also not found that piece and just known like, oh, because this is 180 degrees, these two pieces together, I can subtract 180 directly from 280 to get this missing piece here. And now that I know that that's 100, I can cover again. And you see I have my 2 pieces that make up my semicircle. So I can say 180 minus 100 and get 80 degrees. Now, we can name all the major arcs. For example, we have BCD, which is one major arc. We have ECD, which is another major arc. We have BCE, which is a major arc. We have CDB, CDB, and we have CEB, and I believe that's about it. Yeah. Okay, so those are all of our major arcs. Now we can fill in. Arc BE was 45 degrees because of the central angle. Arc BC was 135 degrees, again because central angle. Angle BAC is the same, so 135 degrees. Arc DE was 80 degrees due to our diameters. Arc DA, or angle DAE, is also 80 due to central angles and arcs being equal. Arc DB was 80 plus 45, which is 125 degrees. Angle DAB, 125 degrees. And arc DC is 100 degrees. And that concludes how to find central angle when given central angle or the arc, depending on what they give you.